Today we're going to talk about the energy consumption of servers in idle mode and when it's in demand, and the performance per language and per framework. Who am I? Some of you might know me. I'm a software developer. I do a freelance for iOS and Mac. Have been doing that for 15 years now, and before that I was an Apple dealer in Amsterdam. I'm also an IoT enthusiast. I have tons of stuff in my house where I measure the refrigerator and the espresso machine and stuff like that. Also a Unix nerd, I can safely say that, since I've been doing that since 1993, I believe, or 91, I don't know. That's who I am. So what about you? Who of you has a website or runs a server? Matthijs? Yeah, everyone runs a server. And where do you do that? Do you do that in the cloud? You do that in the cloud. Bart does it in the cloud. Great, but the cloud is just other people's servers, right? And the nice thing about the cloud is you don't know when it goes wrong. Everything is very nice and sunny and bright. The only thing you have to worry about is money, because once your website suddenly gets popular at Amazon, you suddenly have an invoice of €1,000. It's like, what the fuck happened here? Oh, I used a database, apparently, which you didn't know. So I prefer to run stuff on my own hardware, and at least if it blows up, you don't get a bill. So what does the hardware look like? This is a typical, very small 1U server. And these are stored in racks, and these are stored in huge halls. And I have one of those in a hallway. Let's see what I wanted to talk about. Nothing. Oh yes. So if you want to host this, you can host it in your home, of course. But the problem is these things make a hell of a noise. So I have them stored in a server location using the association CocoaHeadsNL, which I'm also a board member of, but this is not a sales talk, I don't care. I've just been happy using them since 2008 or so. And so it's an association, which means all the members have a say in what's going to happen. And we have about 10 racks divided over 2 co-locations, and you can have all kinds of very advanced networking, but you have to have your own hardware. So, for example, there are some people that have 2 servers which have a failover automatic using BGP, and there are redundant rings, redundant power supplies, and stuff like that. So, one of the things they also do is power measurements, because you pay by the kilowatt hour. So you don't pay for bandwidth. Bandwidth is free. You pay for kilowatt hour, and that's necessary because the more power you use, the more the air conditioning has to cool down your server and the whole room. So it's better if you don't use much power. So what does it look like? This is a typical server. This was my server when it's running idle. So these are basically doing nothing. And when you do use it, you see it going up a bit and then go down again. You see the scale is very, not really precise. And this is done. This is actually what they use for invoicing you at the end of the month. They say, oh, you use this and this much, so you get a bill for that. So they do power measurements for money. And one of the reasons I became interested in it is that at some point, so we have these racks, and they're through another agent who owns the whole hallway. And at some point, that agent, it was called Transipay, they said, yeah, we charge you 41 cents now. We're going to raise it to 65 cents, which is basically like 50% increase. And suddenly everyone's like, oh shit, my 10-year-old server, I need to get rid of it because I need to be more energy conscious. And so I was getting interested in power measurements, and that's what this talk is going on about. So at data centers, most of these servers, they run the fans at full blast because they want a cool server, at a stable temperature, which is better for the server. So I wanted to measure that, and but all the computers are also chock full of sensors So on the CPU alone, there are several temperature sensors, and then on the RAM, and on the ventilators, and on the hard disk, etc. And there is a nice application called fan control, which you can change the fan speed, which is especially nice if you have the server running next to you at home, because as I said, it sounds like a jet fighter going off. And I wanted to measure the temperature, and I used this little thing which I got on AliExpress. This one is called the Sonoff Power 316D, whatever. The nice thing about this one is you can run an open source. You can refresh it with Tasmota, and Tasmota is an open source, IoT gateway, not gateway, but IoT device for really thousands of stuff, switches, lights that you can get on AliExpress and on Amazon and all the other stuff. And so even this device with the display and the fancy, it's supported by Tasmota, and you can then say from, oh, all these measurements, send it through a central server using MQTT, or you can interrogate it with HTTP. It even has a telnet interface, I believe, but I switched that off. And so it's nice. You can refresh it. The instructions are really very simple. You have it refreshed in like a couple of minutes, and most of the minutes is spent opening, screwing the thing. So when you buy it, it sends stuff to China. So don't use it when it's without the refreshing. But now it's all local data. It's all in my house, and it stays there. That's very nice. So I did some power measurements on the server that you saw earlier, and with the fans off, it already uses 28 watts, this is a server from 2013, so it's bloody old. But hey, it was my old server, so I had it as a spare to be able to play with at home. And with the fans standard on, so out of the box, you install Linux or whatever, it's already 54 watts. So it's double the amount just with the fans. It's not doing anything. It's just having fans on. It's like, whoa. That's when I thought, maybe this fan control thing is nice to sort of halve the power usage of your server. And then when you run some stuff on it, the wattage goes up to 78 in this case. But this is a very old server, and it's a very low-powered server. You saw it was a 1U, and if you have like a bigger one with 64 cores and stuff like that, it can easily go to 1,000 watt. Power usage. And so this is all nice, but of course I wanted to test it with software, because it was my idea that software is important for this particular talk. And I wanted to test the efficiency of the various software stacks by measuring how many requests I can do per second, how many correct responses I get, and I want to see the speed, how fast you get a response, the load on the server, if you get any timeouts, etc. And I wanted to do that for the most popular software stacks. And that's the next slide, apparently. So how do I test it? There's special benchmarking software for websites, which I knew the one called Apache Bench, because it's like 20 years old, and I'm 20 years old, so that's like it's cool. And what you can basically say there is, okay, do 10,000 requests for this website, and see how long that takes. And but the problem with Apache Bench is it's very old. It was 20 years old. And it doesn't support HTTP 1.1, which is the keep alive thing, which means for every request, it opens up a new channel, a new connection, does it request, closes it down. So it's very slow. And I thought, oh, so that's not very good. So I moved to, I don't know how to pronounce it, Vrk. So I said Vrk. And Vrk works differently. In Vrk, you say measure for 30 seconds and do as much as you can. And do 100 requests, 30 seconds long. And so I used that, and then I wanted to test various frameworks. So I thought, okay, what's very popular? Oh, Node.js is very popular. PHP is still very popular. Java is very popular. And but of course, I'm an iOS developer, so I wanted to Swift, see how good is Swift as a server framework, because I've been going to server-side Swift conferences for 5 years now. I still haven't got a very good website written with it, but it's still on top of my mind. And now, of course, with Claude, I think, it's so easy to do it. You just need some time. And but then you give a talk and you don't have any time anymore. But these were the languages I chose. Actually, I chose Node.js, PHP, and Swift. And then later someone said, don't you want Java as well? I was like, yeah, if you can make it, okay, I'll give you the Java implementation. So it's very cool. But so what do I want to measure? How do I test? What kind of benchmarks? I needed something that kept the server very busy without using a lot of bandwidth, because otherwise you're measuring your bandwidth. I also didn't want a database, because then you measure a database. It's like, yeah, it's nice if you wanted to test databases, but I didn't. So I wanted to serve a sort of like pure function. I call the server, calculate this shit, give it back to me, and how long does it take? And I thought, with that you can make nice graphs and comparisons. So I ended up with the Fibonacci sequence. So what is the Fibonacci sequence for everyone who didn't pay attention in high school? It's a very simple sequence invented by this guy called Fibonacci. And it starts with the 0 and 1, and then you have this calculation, so you end up with the numbers 0, 1, 1, 2, 3, 5, 8. So that this one is still, these ones added. And why is it a nice thing? Because it happens a lot in nature. Nature is full with Fibonacci sequences. If you see it here, it's sort of like it starts with 1, 2, 3, 5, 8, 13, and all these patterns you recognize when you look in nature. You see, I don't know what's this thing? Snail? It's like shell. It has this exact same form. This weird broccoli thing. Also, sunflowers. So all you see everywhere, you see this pattern. Well, this is just a side note. It's not important for the talk, but I was just like, yeah, nice that you see what math can do. So, disclaimer: I'm not a web developer. I know Swift, but I don't know JavaScript. For that, I hire Yoshikuni over there. I don't know PHP, and I don't know Java. But luckily, there's ChatGPT. So I gave this talk 2 years ago already. So nowadays, I would use Claude because it's better, but I use ChatGPT then, and to create a JavaScript and a PHP implementation. And Swift I did myself. Maybe I should have used ChatGPT for that as well, but yeah, whatever. And so I generated this code, and I put it on a Docker, and I ran it. And it's like, why is Node.js so freaking slow? And PHP as well. It doesn't make any sense. And then this guy gave the Java implementation, and it blew all the others out of the water. It's like, okay, there's something wrong here. So it turns out that the default Node.js and PHP application only run in one thread. I didn't know that because, hey, I'm not a JavaScript developer. And so it only runs on one CPU core, which is a bit sad if you have an 8-core machine. So to work around that, you normally use a proxy, in my case Nginx, which gets the request from the client and distributes it to all the different application servers. So, and this is like the Node.js application or the PHP application. And so you can hit this with hundreds of requests, and it will just distribute it over all these servers. And this is very standard, but as an iOS developer, I didn't know that because you can't know everything. Swift, the Swift framework that I used, Vapor, does this automatically. So basically, this is built in Swift. And in Java, this is also built in, but just not in PHP and JavaScript, which I used. So, when I started doing these tests, what I did is basically, I had a little script that said, do 100 requests per second for the next minute, and see how, this is very irritating, by the way, Marco, that I walk back and forth, because I hear the speaker. Oh, yeah, but Jerry doesn't have anything to do. I keep you busy. So I do 100 requests per second, and then next minute I do 200 requests, 300, 400, 500, up till the server crashes, basically. And it's very nice. So what you see, here you see the number of concurrent requests. So basically you say, very fast, you do 100 requests, and you see the total amount of requests that the server handles using 100 concurrent requests. So this particular server was very fine with handling, I don't know, 13,000 requests per second in total. And then suddenly, when you do 1,500 concurrent requests, it drops down. And for every stack, this is different. So I measured everything. And the one that you saw here, I think that was Java or so. But this one is funny, because this is JavaScript, and it goes very smoothly down. So here I don't see the request, so let me backtrack. This is the number of requests that the server receives before you get a timeout. So there it drops. Here basically you don't get any response from the server. And here you get the number of actual answers that you get from the server. So if you do like 400 requests, all of them you get an answer. But if you do 700 requests per second, only 75% is answered, the rest is just killed. It's like, oh, so that's what you see in your browser. You see like a spinning thing, like, yeah, you just don't get an answer. You have to reload. And when you reload, you do another request, so then the server hangs even more. So that's
not the same as timeout.
No, this is actually you don't get the timeout is basically indefinitely. But I set the timeout to 4 seconds. So these are answers within 4 seconds. If anyone has questions, just do it now. Otherwise, I have to skip back. So here's a little comparison. JavaScript handles quite a lot of requests. So you see here about 30,000 requests. And it drops down after 1,500 concurrent requests per second. But you see already that here, it already drops a lot of packets. You don't get any answer. PHP is also pretty good, but drops already at 400 concurrent requests per second. And Java was very stable, at least on this server. So it could handle like 25,000 requests at the same time before it dropped here. But Swift, it was a very weird thing that we go into later, but was still a lot slower. It could handle a lot less requests than Java. And of course, that tore at my Swift heart, at my iOS heart. It was like, something is wrong here. I should investigate that. And so this is like a bit weird comparison. So let's combine it all into one chart. And then you see PHP at the bottom. And then you see Swift. Node.js, which drops down here. And Java, which I stopped here. And Swift, I kept going because I thought, when does Swift stop? And I stopped there and I didn't continue on this server. So this is a nice thing. So you can say Java is the most efficient server framework, and that's why it's so popular probably in the enterprise world. Currently, I am freelancing at Booking, who still has a huge Perl backend, really huge. They've been busy migrating it for the last 10 years. And so the Perl is probably also very fast, because otherwise they would probably move it to Java quicker. Here you see I probably should have said that, but I don't know. Here you see the responses. So when you do PHP, you get a nice response until you get hit about 400 concurrent requests, and then it drops down sharply. JavaScript, Node.js, we saw earlier, it goes very slowly down. Java stops there, and Swift keeps on going. So I do 9,000 concurrent requests, and it still just keeps on going. So that's strange. When does it stop? We'll go back into that later, but first I wanted to also look at the power, because that was where it all started. I wanted to see the power usage while doing these things. So here you see, for example, with 600 concurrent requests, Swift uses the least power, then PHP, then JavaScript, and then Java. So Java uses the most power when doing all these requests. So this I get from that little device that I showed you. Every time when the script goes to a new benchmark, so we're going 200, now we're going to 300, it gives a little MQTT signal to the server that logs all the data, energy data, so it can give nice heading there. It's like, okay, now we're measuring 200, now we're measuring 300. So that's why you can make these nice graphs, also almost automatically. So what about Swift? There's something weird happening there in Swift land. When does it break? So you saw this previous graph, but you see also there at the end, yeah, when does it stop? And also there's something weird here. See? All the other frameworks basically continue under 100%, but Swift goes down almost immediately. That's weird. So if you zoom into that, you see the Swift, the number of answers that you get. So you do continue to get lots of answers, even if you do go like 40,000 concurrent requests. But it drops immediately from 100 to 97.5. And it's like, this is crazy. Which means you do a request on the server, which does nothing, and you don't get an answer, which is bad. It's not what you expect from a server. So what do? You go into the community. So I asked on swift.org, hey, my standard Vapor website drops 1.5% of requests. And so I just did that. And then it was a huge discussion. It was very interesting. And lots of people showed up. The people that wrote Jonathan Weiss, who wrote Swift Neo, showed up. And there were some people from Google and from what he called? Wade Rodgaskis, who worked at Google and at Apple. And I talk about him later. And they all investigated it. And it's like, oh yes, but this is weird, this is weird. And there were lots of investigations done. So apparently, let's see if we go there. Yes. So this is the guy that wrote Swift Neo, which is underneath Vapor and what's the other framework from Johannes? Huh? Hummingbird. So this is the low-level network framework. And so why is the first request slow? And it turned out that the default setting is accept the first 4 connections, handle those 4 connections, and then later see if there are any other connections, which is normally fine in a normal server, but not if you hit it with 100 requests at the same time, or 400, or 1,000. So basically, it dropped those connections immediately to start working on the first 4. And then they agreed all like, oh yeah, maybe we should raise that limit a little bit. And so that was fun. And the other one, let's see, am I going there? Yes, okay, let's go back. So when I did that, you already see, you see the improvement here, that instead of going down, it stays up till about 500. Still not good, but lots better. Because there was another thing. So I wanted the Fibonacci sequence, but I wanted to use big integers. So it's not really nice that you get like 4.6 times 10 to the whatever. I just wanted to see all the numbers. So for that, I used a big int library for all these different frameworks for JavaScript and for Swift and so. And the thing is, when you Google, I want to use big numbers in Swift, you turn to this big int library. So I thought, okay, let's do that. Great. Turns out that was a very early conversion of a Java library, which was never optimized. So when people notice that, it's like, why do you use big int? You should use this one. It's like, yeah, I don't know. And so I switched that out, and it already became much faster as well. And then this was also interesting. The Vrk benchmarking tool. Wade Tredeskis, who was at the end as well, he said, yeah, I noticed here that there's a lot of sock connect failures in Vrk. Why don't you patch it? It's like, I don't know how. Please do. So he patched this Vrk benchmarking tool because it didn't handle the connect failures correctly. And he put in a patch, and then I can use his patch version to test better. Because basically the responses were not good enough. So Vrk didn't know that the connection was dropped because it didn't handle that. So, and with that, I got new results. Now, you see here the original request from Swift, how many requests it could handle. It's like 8,000 or so. And now with, I have I set the timing to 2 seconds or to 4 seconds, but there's not much difference here. You see the green slightly behind the other one. So basically, Swift could now handle 30,000 requests which is getting close to Java. So I was very happy. And you see here, I also log, so it could handle it, but it still dropped packets. Like it still dropped like 1.5% of the packets. And but it showed it dropped them later, and there was not much different if you say wait for 2 seconds or wait for 4 seconds to decide if a package was dropped or not. So that was nice. Swift was improved. The Vapor framework was improved, and I could compare it much better now with the other stuff, with the other frameworks. So here's latency, which is basically how long does it take before you get an answer from the server. So you do a request, and here I started with 32 concurrent requests, and you see nicely like Swift. Swift is of Node.js is here, Swift is here, and Swift is nicely lower than Java. Yay, we did it. So Swift is faster. Not by much, but it gets better later on. PHP is slower, Node.js is slower, but that's fine. The succeeding answers, so when does it start dropping packets? Well, we already saw this before, so PHP drops very quickly. Java, I don't know how to interpret these things. Maybe Yoshi knows something about it. So at first it's quite stable, you get all the answers, it dips down a bit, there's probably some garbage collection, then it drops down, and then it recovers. You're the expert. What happens? Ghosts. I mean, you see here that Java and Swift keep pretty much at the correct level until very high numbers, which is nice. And response time. So I don't know what the difference is between response time and latency. Did I write it down somewhere? No. Maybe latency is when the server recognizes your request. So you get like an ACK, like I received your package, and responses when actually the server gives you an answer to the calculation. And here you also see that Swift and Java are really close, and PHP and JavaScript. Yeah, I sort of combine JavaScript and Node.js because Node.js is the framework, JavaScript is the language, and I used Node.js here, and I didn't use Vapor there, but Swift, but it's all interchangeable because, yeah, if you don't, ask me. But here, this is actually where the big differences go. So the problem nowadays, especially now with RAM prices, I don't know if you wanted to buy a server recently, but memory is very expensive. And even in the past, the bigger servers had like 1 terabyte, 2 terabytes of RAM because of, oops, wrong button, because of Java. Java uses all the memory it can get for optimizations. So basically, it doesn't really calculate things. When it already knows it and has it stored somewhere, it can give you the answer immediately, so that makes it very fast. It also means that for this simple calculation, it already used up 1.3 gigabytes of RAM almost continuously. And Node.js also uses quite a lot, and then PHP less, and Swift uses about 50 megabytes. Which means, in my humble opinion, that technologies matter. Which also means that like, if you run multiple applications on your server, you can run 10 different Swift applications, because they all use about 50 megabytes. You end up with 500 megabytes, which is still way less than this one application in Java land. Because Java uses just way much memory. And this scales, of course, if you have a server with 1 terabyte. This server only had 8 gigabytes or so. And yeah, Swift just scales way better. And there's lots of, if you ever go to the Swift server, server-side Swift, like yes, there are nice talks from, for example, Things or Amazon that switch to Swift. Amazon uses Swift to ingest videos for Amazon Prime because it's just more efficient. What else?
On the Java memory, that's the pre-allocated heap size, right? For the JVM.
Yeah.
Customize that.
Yes, but you want to customize it for speed, probably. And probably they lower it for things. What I noticed also in another graph, you see it goes up, and then it goes down. So the garbage collection, and the response goes down as well. And then it goes up again, and it goes down. So you see Java garbage collecting all the time. I didn't put the graphs in here, but you see it sort of like the garbage collection of Java and JavaScript as well. The JavaScript, you see the same thing. It rises, dips a bit, and then it rises again. And Swift just stays stable because once you have the memory allocated, it's there, and it doesn't need any more. For this particular application, of course, that's always important. So, indeed, technologies matter. And of course, if you have more modern computers, this one is from 2013, you can run way more and much more than I did on this machine. And of course, newer CPUs have way more performance. And so you can use less hardware for a particular application. So if you have like an application that uses 5 servers, replace them with 1 new server, great. But then you miss the redundancy, so you need 2 servers. But 5 servers is still nothing. So if you have, let's say, 1,000 servers, and you can divide it by a factor of 10 by switching to Swift, then suddenly it makes a lot of sense, because you spend way less power than if you continue in Java, in my humble opinion. And you also see, of course, these bigger cloud infrastructures using ARM over Intel, because ARM is also way more efficient. And I think I read recently that a lot of LLM guys and girls use Apple Macs because they're A, very fast, and B, very efficient in memory and power-wise. So I also have a newer server, which replaced the other one, which was, I don't know what, 2021 and 13 it says here, yeah. So I bought a new server in 2021. There I ran the same benchmarks. So you see here on the old server, this is Java. The old server handled about 25,000 and the new one handles about 40,000. So even though it's 8 years younger, it's still not really a huge leap in consumption. Where it does shine is because it has way more memory. Java basically never failed. It just kept on going. I basically stopped at 70,000 concurrent requests because it's like, this is crazy, silly. And I didn't have a Swift slide for that one. That's a shame, because I wanted to do the Swift slide as well, but I had to. It was too much work. So, conclusion. From the very beginning of the talk, if your idle server runs fans full blast, if you slow it down, you can already save maybe 50% of your power consumption, and thus the cost. And of course, use appropriate tech. You can add servers, or you can use a different tech stack. So you can have the same or even more application power with less electricity power. And and then of course became the afterthought, what's the point? Because this is a current data center for AI. And these are all GPUs which use huge amounts of memory, of power, like gigawatts of power for one data center, and swimming pools of water every hour. So we can do our tiny little bit to be more energy conscious, and then you have these companies that sort of throw energy down the hole. It's like, well, that's a bit of a sad ending of my story, sorry. So acknowledgements, you can find all the code that I wrote on my GitLab, not GitHub, careful there. I would like to thank Gerard de Leeuw from CocoaHeadsNL, who wrote the Java benchmark, and Jelle, who wrote the JavaScript, who helped with the JavaScript benchmark. Oh no, the PHP. He basically said like, oh, you have to use proxy in front of it. Okay, thank you, Jelle. Because of all the discussion on Swift.org, I put everything in a blog post as well, because I had to point people to it, so you can read everything that on my blog. And this is this guy. He analyzed the work response, and he gave a meta. He wrote a meta blog. Swift sucks at web surfing, or does it? And as a response to my blog post, and it's very very technical. that's it. Thank you. Any questions? Shoot. Oh, yay.
Yeah, so I did a back of the napkin calculation using Claude. I said, what if we would use JavaScript only where it belongs in the browser? So no Node.js.
Ah, good one.
No, what is it called on the desktop? Electron.
Electron, yeah, just
Node.js,
Node.js
native apps and Java or
script.
better on servers. How much power would we save? And I didn't
What did Claude
check
say?
it to death, but Claude said that it's about the electricity consumption of England, of the
England.
UK. just because some people can only program in one programming language.
Yeah, probably. But I don't know. It would be interesting to see how much energy you use if you would run everything there, not on a very old Intel-backed machine, but on an M4 or so, and see what it there. But good Dockers on M4. What else?
So your Swift experiment that runs its own web server with Swift Neo, if you ship that to production, you probably put Nginx in front of it, right, with a proxy. And if you do that, does that fix your problem with the connection pool?
Interesting. Probably also. Yeah, because now I use the connection pool of Swift Neo, but the Swift Neo is now upgraded, so that doesn't matter. And it's always, but then of course you need that if you want to distribute it over multiple servers or so. So you probably, everyone uses some sort of front end like Nginx, or there are specialized hardware to distribute stuff, also to protect your servers. And yeah, that might be interesting. I haven't, but I always think if there's something before, it slows it down. So if you don't need it, you probably not. But with JavaScript and PHP, you do need it. So
You have to.
yeah, and with Java also, it has its built-in distributor of packets. So that's like, and it's optimized for servers. So why switch it out for something else?
Thanks.
Yeah.
Anyone else? Here we go.
Hey, have you tried Elixir or Erlang that runs on a Beam?
Erlang
runtime?
would be interesting indeed, because
Yeah.
I did some Erlang programming, and it's also meant for servers. But at some point you have to stop, because there are like 5,000 programming languages. I also didn't use brainfuck and stuff like that. So
Erlang or Elixir is famous for handling the concurrent things very effectively.
Okay.
So that's a go-to if you want to have the concurrency.
yeah,
So
Rust and
maybe-
Go as well, of course. Yeah.
Yeah, but Elixir or Beam runtime that Elixir or Erlang is on is built by the telecommunication companies, and it's used for the WhatsApp or Discord.
Oh, really?
So, yeah, WhatsApp or Discord is using Elixir or Erlang.
Cool.
So that's handles a lot of concurrencies effectively. So maybe if you try that, you can have a
Give me a
different
pull request, I say then.
So is the pull request possible or can you find the REPL? Oh, that's the top one, of course. Yeah, cool. So
Yeah.
I'm interested in adding Rust and other compiled languages.
Yes,
because I
exactly.
think
Rust is also very fast.
one of the biggest differences, of course, between Node.js, PHP, Java, and Swift is that it's pre-compiled. So the rest is all interpreting stuff. So it's doing work.
Only Swift is compiled.
Swift is compiled, so it's doing work up front, which you
Yeah.
don't spend later. So comparing it to Rust and C++ maybe actually be...
Yeah, I don't think C++ is very popular anymore in serverland, but Rust definitely is, and of course Go is also especially meant for
Yeah.
server applications. So
It'd be interesting to
I can
compare.
maybe ask Claude, or I delegated to
And-
to make a Claude, ask Claude to make a Rust implementation.
And then maybe like another conscious question is about the wattage of the server after running or after these optimizations. How big of a usage do you have on the server that it's actually is relevant?
Yeah, so maybe the server is basically flat out. It's like going full blast. You see all the CPUs going at the top,
Okay. Yeah.
and then when you stop, you see it immediately, of course, go down. It's not like it is a remnant
So
there.
it was for all the languages, it was 100%.
Yeah.
Okay. Yeah. The same wattage as well. Yeah. Yeah.
No. That's a funny thing. They all went to 100%, but as you saw in the first slide, Swift was still less than Java, or the other ones. So of course, CPU is not only the thing that uses a lot of power. RAM apparently uses also a lot of power, even though you think it's there and it just stays there. So what happens here? I can't explain that. If there are any hardware guys and girls here, please help me. But I can't explain. They all go full throttle, but you do see a wattage difference. And crazy.
Cool.
I know. Cool. Any more questions? No. Oh, yes. Tom.
Yeah, so
Yeah.
for Swift, you went into the forms to get it faster, but you didn't do that for PHP or JavaScript.
Good point. Because I'm a Swift developer. I'm prejudiced.
Unfair.
But I did get help from Java people and from the JavaScript people. So then I think, hey, your problem. But fair point. Shit.
Basically, she's just shit talking from Swift to other people.
Yeah, exactly. Next time I will do it in shell script, see if that's faster, and then have all the Unix nerds come over me. Oh, you used Bash. You should have used C shell. It's like, oh, whatever. Okay, thank you, and have a beer.